In our video today, we are going to be covering rectangular coordinates and graphing. Both of these are covered in 4.1 and 4.2 material, and I didn't like that they had them spread out when I think a lot of this stuff goes together pretty organically. So I've combined these two sections together as one single video and one single set of lecture notes. I'll let you know when we get to the quote-unquote second part of this, because there's a couple things that 4.2 does bring in that's slightly different from graphing, but we'll get to that at the very end. So, starting with our basics, if we are going to graph anything in this class and our future classes, here's how we are going to go about starting that and setting these things up. For my particular class, these are an absolute must requirement for all of your graphs. If you are not including any one of these or more of them, then I will not be grading your assignment. I will not be grading, I will not be grading the test question, and that question will automatically be given a 0. These are the requirements that we need for all of our graphs, and I tend to find that anyone who is missing one or more of these generally starts to get wrong answers on graphs anyways. So what are these? And then we'll take a look at two ways of writing this out and expressing this for our homework and for our tests in my class. So we want to set up our set of axes. That's the horizontal and vertical axes that we normally see with all graphs. We want to label the axes, which one's the x-axis, which one's the y-axis. When we get to stuff later on in this class, in future classes, we're not restricted to just the x and y values as variables. We can have t, we can have h, we can have a, we can have m, we can have n. Bunch of different things that can be showing up. We want to make sure each axis is labeled accordingly. We also want to define which direction is positive and which direction is negative on our sets of axes. We generally think that going to the right on the horizontal axis is positive, and going up on the vertical axis is positive. And while that is true, we do want to make sure that we actually label that for ourselves, specifically to help with the last requirement here, which is that we are scaling our axes accordingly. Am I counting every single tick mark on the grid going horizontally by 1s, by 2s, by 5s, by 10s? And then the same thing with the vertical axis. Am I counting the vertical axis by 1s, 2s, 5s, 20s, 100s, whatever that may be? We're going to take a look at two ways that we can organize this. If you are in my class and you're watching this video, these two methods that we have to organize and set this thing up are both perfectly acceptable, or some combination of both of these different ways of showing it are good. But again, both of them have all four of these requirements in those. So before we dive into those, make sure that we are making these things labeled and as neat and organized as possible. When we are getting tested on this stuff for my class, I will be providing graph paper on tests, so you will not need to worry about looking at that and figuring it out on lined paper, or how do I do this with blank paper. You will be provided graph paper to help out with that. So let's go through two ways that we can organize and set this up for ourselves. So I'm going to go scroll to the right here, and I have two sets. Actually, I'll zoom it out here a little bit. There we go. So I have two sets of axes written out here. So first and foremost, we're seeing our horizontal and vertical axes set up there. Fantastic. We see with this left one, both sides of the axes are labeled as x and y, perfectly acceptable. On this one, we only have one of the axes, or one end of the axes, labeled as x and one labeled as y. This is also perfectly acceptable. Now, getting into the more specific parts of making sure we have the positive and negative directions labeled with this, a couple ways you can do this. Looking at our first one that we have here, you can put a plus and a minus in front of each of these labels that we have here. That's perfectly acceptable. For our other one, we're going to go about showing that in a slightly different way here shortly. Now we need to set up and scale these things accordingly. So each of these tick marks needs to represent something. How much am I counting up by, counting down by, anything like that. So each of these axes can have its own individual scaling, but that entire axis needs to have the same one. So what that means is this entire y-axis I could be counting by tens, and then the entire x-axis I'm counting by ones. That's perfectly acceptable with all graphs. There's nothing wrong with that, as long as you stay consistent along that entire axis that you are currently labeling. So for our first one that we have here, I'm just filling in some of the tick marks on our second one as I'm talking about this. For our first graph, let's go ahead and scale this accordingly. Now I'm going to scale my horizontal axis by 1. So every tick mark I'm counting up by 1. So I have 1, 2, 3, 4, 5, and 6. Go in the positive direction. Negative direction, I have -1, 2, 3, 4, 5, and 6. So I have my x-axis labeled, I have the positive and negative direction defined, and I have it scaled accordingly. I need to now do the same thing with my vertical axis. And again, our vertical axis can go by a different scaling if we'd like to. So for the sake of showing it, I'm going to go and write the y-axis as I'm counting by 5s. Could be by 1s for the problem you're working on, could be by 10s, by 2s, your choice. But we do want to still label it accordingly. So again, I'm going to go by 5s here. So I would have 5, 10, 15, 20, 25, 30. And then the same thing in the negative direction. -5, -10, -15, -20, -25, -30. So there we go. We have our axes written out. We have them labeled at the very ends. We have the positive and negative directions clearly defined. And then we have each axis scaled accordingly by every tick mark. So this is if you want to include everything with every single detail included along the whole thing. Now, over here with our second option for writing these things out, this is if we're going to take a little bit of a more minimalist approach to organizing these things. This is perfectly acceptable, but again, I will show you the bare minimum requirements that you still need to have. If any of these are missing with our kind of our pared down version of this, I will still not grade it on the test and I will give it a 0. So let's go with our x-axis. Let's scale this thing and get the positive and negative directions defined. Now I'm going to do the x-axis by 1s just like I did with my first one here. The only difference that I'm going to do is I'm not going to write it out for every single tick mark. Maybe you're looking at this going, this gets really busy and I don't feel like I'm going to have enough space to write and graph things out accordingly. Fair enough, there's nothing wrong with that. So instead, I'm going to count out 1, 2, 3, 4, 5, 6. So I'm going to have 6 in the positive direction, 1, 2, 3, 4, 5, 6 in the negative direction. Now my recommendation is about halfway through this whole axis where it ends here, put the middle number. Just so we know 1, 2, 3, okay, the halfway, 4, 5, 6, okay, we're good there. Same thing on the other direction. So I now have my positive direction and my negative direction defined, so we're good there. Maybe I'm going to do the y-axis, instead of by 5s, let's go, I don't know, let's go by 2s. So I'd have 2, 4, 6, 8, 10, 12 would be up here. Then let's get something halfway, 2, 4, 6, right there. Same thing in the negative direction, -2, -4, -6, -8, -10, -12. And there we go. We can see here I still have my positive and negative directions defined, and I have my axes scaled accordingly. I just have it a little less busy along each of these axes compared to my first one that I have here. So either combination of these, if you want to commit to just doing this one, that's great. If you want to commit to doing this one, that's great also. If you want to do some mix and match of these things with our labelings and whatnot on the ends of the axes, you're more than welcome to do so. But this is a bare bones minimum requirement for all of your graphs in my class for me to grade it as potentially worth credit on tests. So a quick example of how we get those set up there. Let's go ahead and scroll back over to our notes and let's actually graph some things here. So when we are plotting points, zoom this in a little bit. When we're plotting points, we want to make sure that we start at the origin and move in the corresponding number of places based on the ordered pair's number and sign. So what that means is we have to be given a point or an ordered pair on to put onto a graph. Points and ordered pairs, by the way, are representing the exact same thing. It's just something that we would put on a graph. So these are our 4 examples that we're going to use. And I'm going to go ahead and jump us over to a different screen, and we'll take a look at each of these in a bit more detail all by themselves. All right, so let's go ahead and graph these 4 points on our set of axes over here. I do want to go through, before we do that, some universal truths and universal facts regarding ordered pairs and how we determine which number corresponds with which axes we are working with. So as a generality, when we have an ordered pair, the first number is considered to be the input value. The second number is considered to be the output value. We'll see this and what this looks like in a bit more detail later on in this class and in future classes, but as a generality, the first number is the input value, the second number is the output value. Going a step further with this means that the input value could be x, it could be t, it could be n, it could be h, whichever. It'll depend on what units and variables we are working with in the particular problem that we are given. Now, the main thing that we want to know, though, is that when it comes to graphing these things, the input value is always going to correspond with the horizontal axes. I'm just going to do horiz for short, horizontal. So it's always going to correspond with our horizontal axis here and tell us if we're going to be moving left or right in the positive or negative direction based on what our labeling is looking like and what this number is. So if the input value corresponds with the horizontal axis, the output value is going to correspond with the vertical axis. I'm just going to do vert for shorthand here. And that's going to tell us if we're going to be moving in the positive or negative direction along the vertical axes for our problem. So with graphing each of these things, we always start at the very middle of these graphs, right? The origin. This is considered to be 0, 0. I'll write that in here for us just so we know, have that in. So this is the origin, and it is always at the point 0, 0. So from the origin, we determine what point are we working with and then use this bit of knowledge to tell us which direction we are moving in horizontally and vertically. So with the point 2, 4, starting at the origin, I'm moving 2 in the positive direction and then 4 in the positive direction vertically. So 2 horizontally and then 4 vertically. This is where we need to keep track and keep in mind how we have labeled and organized these things. So I'd be going over 1, 2 places on the x-axis, but as I'm going vertical, I'm not going to count up 4 because how have I labeled my vertical axis? Well, every single tick mark is 2. So I'm going over 1, 2, and I'm going up to 4. So here is my first point, 2, 4. So keep in mind how you have that organized for yourself as you're plotting these things. As soon as you have differing axes and different scalings, that's when it can get a little tricky, so make sure you're tracking that. So we're working with our second one, negative 1, 2. Again, starting at the origin, I'm going negative 1 in the horizontal direction, so I'm going over by 1 here. And then I'm going 2 in the vertical direction positively, so I'm coming over 1, going up by 2. Remember, our axis is counting by 2's here. So I have the point negative 1, 2. This labeling, by the way, is not required, though it is certainly helpful as you are going through and graphing these things. Let's graph our third point. We have negative 3, negative 5. Now, I just want to show another route that some people like to take when graphing these things. Some people like to take and put dotted lines on these axes as we're tracking out from the origin. You're more than welcome to do that. It's certainly not a requirement, but it can be helpful as we're starting off with this. So graphing negative 3, negative 5, I'm going to be counting over negative 3 places horizontally here, and then negative 5 vertically. So I'm going to go down by 5. Now because I've scaled this thing by 2's, that means where is negative 5? It's going to be right in the middle here. So I'm going to have to come down to about there. So it's halfway between 4 and 6. And go ahead and label that. And then my last point over here at 5, 0, again, I'm working horizontally first. So from the origin, I'm moving over 5, which is going to put me right here. And then 0. That means I am not going to move up or down vertically in any way, shape, and form. So the point 5, 0 is just going to sit right on the x-axis. And this happens fairly regularly with our points on the x-axis or sometimes on the y-axis. There's nothing wrong with it. It just tends to happen from time to time. So make sure as you are going through and graphing points, whether it be in this section or future sections when we are actually graphing equations, that we think of our input value and output value as the first thing and the second thing. And then the input value always corresponds with our horizontal shift. The output value corresponds with our vertical shift as we are graphing these points. The second part of what we're going to discuss today is how to plot a graph. Maybe we're given some sort of an equation like we have down here, y equals 3x plus 2. Maybe it's something like y equals negative 4x minus 13, something along those lines. How do we go through and actually plot that thing on a set of axes? So we're going to go through over the course of chapter 4 a couple different ways that we can go about doing that. So this method that we're going to go through this video is not the only one that is available to you. We will learn more later on. And when we have all of those nailed down on the tests, I do not care which of the methods you would like to use. Pick one and then you commit to that. So for the 4.1 and 4.2 stuff, here's what our method's going to be. We are going to create and label a table of points, kind of like what we see down here. Here's our x values, here's our y values, and then here's our ordered pair, everything written together as a single point. For linear equations, which is what we are going to be working with, we need at least 2 points or ordered pairs, but if we have more than that, like 3 or 4, that is also perfectly acceptable. Depending on the class that you are working in and what you're working with, you might be asked to find and create a table of 3, 4, 5, or more points, and then graph each of those on the set of axes that you're working with. For my class, and really linear equations in general though, you only need 2 points. That is the bare minimum requirement to be able to graph these things. We're going to find a couple more with our example, but again, bare minimum, we need 2. So when we are going through and plotting these things, we get to choose the, what's referred to as the independent variable's value, the input value. We can choose any number that we would like to be our x value or our input value. This means that you can choose the number 0, the number 1, the number 5, the number negative 3. Maybe you want to go and use something like negative 5,268.73. Maybe you want to use the number 1 million. It is entirely your choice on what input value you would like to use for this ordered pair. We then need to go through and calculate what is the corresponding dependent variable or variable's value, also referred to as the output value. So we can choose an x value to plug into this equation. We then go through and calculate by hand what is the corresponding y value or output value that goes along with that one. And we do this 1, 2, 3, however many times a question is asking for us to do that. But again, if we are just asked to graph something, we need a minimum of 2 points. If you have more, that's great, but minimum of 2. Now, big warning here with this, because a lot of people misinterpret what this bullet point means. You cannot choose an input and an output value for an ordered pair. That's the equivalent of taking a set of axes and randomly picking a point on there and saying, I think this point is on that graph. Maybe it is, maybe it isn't. You don't know. So we can only choose an input value, and then we calculate what is the corresponding output value that goes along with it for this specific equation that we've been given. So you can only choose one. You can only choose the input value. We have to calculate the output value. Once we've done that, we can then plot each of these points on the set of axes that we've been given, and we connect them together with a line. I'd recommend using a ruler, or in a pinch, use a credit card or something like that, edge of a book, to help make a straight line to connect everything together. The program that I'm using here doesn't always allow me to do that particularly well, so you'll see me do that freehand a little bit, but you're welcome to use a ruler or something like that to go through and connect those points together. So we're going to take a look at the example y equals 3x plus 2, and we're going to go through this process and graph this thing. So we were told to go through and graph the equation y equals 3x plus 2. So we need to first find at least 2 points to plot on this set of axes, and then we can actually go through and create our equation from there. So it's your choice if you'd like to do the entire setup of the axes first, or find the 2 points that we need, or more if we're asked for more, and then set up the axes. I'm going to go ahead and solve for the points. That might give me some insight as to if I need to scale anything by 1s or 2s or 5s or anything along those lines. But the order you'd like to do it in is entirely your choice. So I'm going to create a table here where I have my x values in this column, I have y values in this column, and I'm going to have my ordered pair listed at the very end here. I'm going to use OP for short just so I don't run out of space with this. Now, at this point in time, we get to choose what we would like our input value to be. Remember, you can choose this to be anything. It can be a big number, it can be a small number, it can be a fraction, it could be a decimal, it could be 0. 0 is one of my personal favorites to use with these. So I'm going to go ahead and choose my first ordered pair. I'm going to choose the x value of 0. Now we need to calculate what the corresponding y value is going to be. So over here, I'm going to write out for myself. I'm choosing x is 0. I'm plugging 0 in for x in my equation. And I'm just solving this thing for y. So 3 times 0, that's going to give me 0 plus 2. That's going to give me 2. Great. So the y value that goes along with an x value of 0 is 2. So this whole thing as an ordered pair is 0, 2. And now I need to find at least one more point to be able to graph this thing. So I'm going to go ahead and divide this up here. What's another x value that we could use here? Could be a positive, could be a negative. Again, this is entirely your choice. And I'd recommend as you're going through these, pick nice, easy numbers to work with for yourself. I think numbers between -3 and +3 are generally a good starting place. And honestly, 0 and 1 are always really good starting places if we have integers here. So okay, I chose an x value of 1. Let's go ahead and write this out for ourselves. Plug this in. And let's solve this out. I have 3 times 1. It's going to give me 3 plus 2, which is going to give me 5. So great. I have an input value of 1, an output value of 5, which means I have the ordered pair 1, 5. Now let's say you were asked to find 3 points that are on this thing. So maybe we need a third one. Technically, we're done after having these two for graphing this, but let's say we're asked to find a third, just for the sake of getting some practice in. What number would we want to use as our third number for our input value? And again, this can be anything you want. It can be 2, continuing on with the trend of counting up. It could be -1 if you want to go and get a negative value here. Really, truly doesn't matter. So I'm going to choose -1 just for the sake of seeing a negative value being used. We get a y value of -1. I can plug this in right here for my y value. And then what's my ordered pair? I have -1, -1. Fantastic. So I have 3 good points here that I can choose from. I could write out and find more of them if I wanted to, but again, bare minimum, I need 2. We did 3 just for the sake of seeing some extra examples with it. Now looking at my axes and my numbers, I don't have anything that's particularly big or particularly small with that, so I'm going to go ahead and label this thing accordingly and get this all set up for myself. Now that I have all of the axes set up and labeled accordingly, I have my X and Y axes labeled, I have the positive and negative directions labeled, I have everything scaled as necessary. I'm just counting everything by ones. Now I can go through and actually graph these things. So I'm going to use blue to represent the points on this graph. So I'm going and first plotting 0, 2. So 0, 2, that's going to be right here. Then I'm applying the point 1, 5. So I'm going over by 1, counting up by 5. That puts me right here. And then, technically speaking, I could connect these things together. I'm going to go ahead and graph this last one here as well. I'm going -1, -1. There we go. And now, connecting these things, see how that, let's give that another go. Second time's a charm, right? There we go, that's better. And again, if you have a ruler or a straight edge or anything like that, you're welcome to use that to help you actually graph these things. But again, I find as you're going through these, make sure you have the axes set up properly. When you are choosing your input values, they can be as nice and easy as numbers that you're using over and over again, like maybe 0, 1, and -1, or you can make them as complex as you possibly want. It's your choice. But my recommendation is that you choose the easier numbers every time, at least to start with. The last final word in terms of graphing equations, we have 2 special cases of lines that we can see showing up. And those are horizontal lines and those are vertical lines also. So horizontal lines are always going to be in the form y equals just a number. It could be a positive, could be a negative, could be a fraction, a decimal, or 0. Then we have vertical lines, which are the form x equals a number. And again, that number could be a positive, a negative, a fraction, a decimal, or 0. So be on the lookout for some of those. If you're told to graph just something in these forms, this is what we're going to be using. And the nice part about that is if it's a horizontal line or a vertical line, I'm going to make just a quick set of axes here to show this. It's not going to be particularly detailed, but follow me with this. We'll use our blue for a horizontal line, and we'll use green, if it'll stay. There we go. Blue for horizontal, and we'll use green for vertical. If I do have a horizontal line, that means all of the y values are going to be the same. All of the x values can change, but we don't care because y is staying the same. Vertical lines are very similar, except that the x value is staying the same and the y value is changing. So it would be something that looks kind of like this. So be on the lookout for those. Those show up from time to time, but just want to make a quick mention of that. Now, the last major part that we want to talk with about this material, and this is kind of sort of tacked on at the second half of 4.2, is finding a solution to an equation when we have 2 variables showing up in it. So we're generally going to be given an equation and we're asked, are these points, or are any of these points that we have here, solutions to a respective equation? So what we are just doing is checking, are these points on the graph? The way we do that is if we substitute x and y for a and b, A and B are the two numbers that we've been given in the new ordered pair. And a two-variable equation for the respective variables produces a true statement, which is a really fancy book way of saying if the left side of the equal sign is equal to the right side of the equal sign, the ordered pair AB, or whatever those numbers are, is a solution and therefore satisfies the equation that we have been given. So all we're doing is plugging some numbers into an equation, simplifying each side down, and seeing what we get from there. So our example that we're going to go through with this is we're being asked which of the ordered pairs is a solution to the equation y equals x plus 2. We've been given the point 4, 4. We've been given the point -1, 0. So let's go ahead and see what that looks like and how we solve that in practice. So looking at our last example, we are asked which of the ordered pairs is a solution to the equation y equals x plus 1. We're given the first ordered pair of 4, 4 and the second ordered pair of -1, 0, and we're asked to figure out which one's a solution. Now I'm doing both of these at the exact same time, or really close to the same time, because there's really not a whole lot that's unique to them and different about how we go about solving them until we get to the very end. So all I'm doing for both of these in the first step is I'm plugging in the input value for x and the output value for y based on the ordered pair that I'm working with. And after I've done that, then I'm just going to simplify. Remember, that's just using PEMDAS, not moving things around. Just simplifying the left side of the equation, simplifying the right side of the equation, and then we can reach a conclusion from there. So I'm going to go ahead and show that for both of these ordered pairs here now. And once we get down to this step where we have a number equals a number, now we can go and see for ourselves which of these things is or is not a solution. Well, when we have something weird like this showing up, 4 equals 5, well, this is clearly a false statement. That means that the point 4, 4 is not a solution. We can go ahead and write that in as our answer. I think on a fair amount of online programs, they'll just ask you to select from a drop-down menu, is a solution, isn't a solution, something like that. On the test, I would be looking for you to write out not a solution to this part of the problem. Now in contrast, that over here we have two numbers and both of them are the exact same thing. And because of that, that tells me that the point -1, 0 is a solution. We want to make sure that we have that written in as well. So it's not a particularly grueling and terrible process, I don't think. Just make sure you're taking the time to correctly plug in the input value for x, output value for y. Input value for x, output value for y, as you're going through and setting these things up for yourself. As a recap of the topics that we covered today, we were working with the rectangular coordinate system and working with how to graph those. So we had our 4 main requirements for going through and graphing these things. If you are not in my class, you are not required to do these. I just think these are very good practices and very good habits to get into when you are graphing equations. I tend to find a lot of headaches show up when students aren't doing all 4 of these on their homework assignment or on a test or something like that. If you are in my class, then these 4 requirements here you must have on all of your graphs. If you are missing one or more of these on a test, I will not grade your graph. It will be put into the grade for that test as a 0 for that problem. We had 2 examples here off to the right. See if I can scroll this thing over. Maybe it'll let me. There it goes. We had 2 examples of what this can look like for setting it up. And again, we had a full detail version over here on the left. And then we had a partially detailed, maybe kind of a bare minimum setup on the right side. either of these in my class are perfectly acceptable, or some combination of these is perfectly acceptable too. We then went through and actually plotted 4 separate points on the set of axes, noting which one is our input value and output value, which one moves along the x-axis, which one moves along the y-axis. Then we had our process for actually going through and plotting graphs. Remember, your bare bones minimum requirement for a linear equation, which is everything we see in here, means that you need at least 2 points. If you have more than 2 points, great, but you need at least 2 to be able to graph these things. We find those 2 points by choosing the input value, or x value in this case for our example, and then calculating the corresponding output values that went along with those. We graph those points, and then we have our answers. We had our quick mentioning of the 2 kind of special cases of linear equations, vertical and horizontal lines, what each of those looks like on a graph, and some characteristics of the equation themselves. And last but certainly not least, we determined how do we find a solution to an equation if we are given 2 variables. So we're given something, we're checking, is this point a solution? Yes or no. Is this point a solution? Yes or no. And all that is just plugging in the x and y values into the equation and checking to see if both sides are equal to each other or not. If they're equal, it is a solution. If they're not equal, it's not a solution. And that's everything for the 4.1 and 4.2 material.